Listen to this. Okay, girls, please put away your devices. Please take out your workbook. I'm sorry? Uh, Pretty much, I think you are. All right. In 1966, a Miami boy smuggled 3 giant African land snails into the country. His grandmother eventually released them into the garden, and in 7 years, there were approximately 18,000 of them. So we started with how many? And we got to 18,000. The snails are very destructive and had to be eradicated. What does that mean? They had to get rid of them, okay, by dying, yes. According to the USDA, it took 10 years and cost $1 million to eradicate them. Letter A, assuming the snail population grows exponentially, write an expression for it in terms of the number T of years since their release. Okay. First of all, we are talking about exponentials in this module, okay, where things either grow very quickly or decrease, okay, very quickly. All right, can someone remind us of what that exponential equation looks like? Uh-huh. Okay, to the exponent of t, which is time. Rowan, put away your device. Okay? Open up your workbook. It's out, but I need it open now. All right, so A, right now, since it says write an expression of it in terms of the number t of years, we're going to say A of t equals, now we know anytime there's an equals, we actually call that an equation. So we're focusing on this part of it as the expression. Okay, what does capital P represent? Time. The initial amount, P, not T. P. Oh, I thought you said T. Right. And how many snails did we initially start with? 18,000. No, we started with 3. Wait, where did we get 3 from again? Right here. He smuggled. So he must have gone to some African country, maybe, came back, brought back a land snail. We looked up land snails. They're about the size of a small rabbit. Now, you know snails are usually like this. I mean, we're talking a rabbit you could hold in your hands. That's kind of scary. You know, and the 2 little eyeball stalks. I mean, it was gross. It was gross looking. Times quantity. The 1 is going to stay the same. If we go from 3 to 18,000, is that an increase or a decrease? Increase. So that's going to be plus R. Do we have the rate? We do not. We do not. So we're going to keep that as just R. Well, it doesn't say approximately 18,000. You know it's not a rate. Well, that's not a rate. That would be more the ending number. Okay. And then our time, write an expression for it in terms of the number T of years. It's kind of weird what they're asking here for it in terms of the number T. So I'm not sure if they're really wanting T, but in this problem, we actually know T would be 7. You're looking at how long it took to get rid of them. We're talking about how they multiplied rapidly. Okay? So, not sure. We can put T, which is equal to 7, maybe. Because they want it in terms of T, but we know T is 7 here. Does everybody see what I'm doing? All right, so this, I think, is probably the best answer that we have going for that first problem. Any questions about that? Any questions? All right, letter B. I just think that seems like a song. Letter B, letter B, letter B, letter B. By what percent did the snail population grow each year? All right. So again, let's start with A equals P times 1 plus or minus R to the T. Do we know what the final answer is, or the final amount when it comes to these snails?
No.
Yes. You need to slow down and read a little bit. You're like,
I don't like reading.
you keep looking at the whole other thing. What is the amount? No. 18. Yes. So we're talking about 18,000. That is the amount that we ended up with. How many did we start with again? How many? 3. Times 1. We said this is plus. They are increasing. The rate we do not know. And we said the time was how long in years? 7. So now we are trying to figure out that rate as a percent. All right. And we've got lots of fun little numbers here.
Divide 3 to both sides.
Excellent. Yes, you would divide by 3. It's almost like if I have 3 times some big number there, you would divide by 3. So let's divide both sides by 3.
6,000.
So the 3's simplify out. We get 1 plus R to the 7th power is equal to 6,000. Now,
wait, no, that's square root.
not the square root, but the...
Distribute.
Huh?
Distribute.
No, you can't really distribute a power.
Distribute the exponents.
You don't really distribute exponents. Not very easily. You can kind of do it, but no.
1 in R.
No. No. What is 1 plus R?
1 R.
No. It's 1 plus R. You can't simplify that. We don't know what R is. We do. Yeah, but there's a much easier way to do that. So let's say, let me give you some illustrations here. Let's say I said that I had 25 is equal to x squared. How would you find, Shay, how would you find x? What would you do for that? You would take the square root. And when you take the square root of a square, it would cancel out. So x equals plus or minus 5. When you're dealing with an x, you have a positive and a negative. So what if I had x to the 3rd equals 27? You would take the cube root. We have to take the 7th root. Yes. And here we would get x is equal to 3. Here, when you take something to the 7th power, kind of look at it and say, let's pretend that's x to the 7th power. So we would take the 7th root, meaning what number times itself 7 times gives you 6,000. Question. Where did I get what? Oh, I just made this up. So I'm just showing if you take x squared and take the square root, that's how you get 1x. If you have x to the 3rd power and you take the 3rd root, those cancel out. If you add x to the 6th power equals some number, then you would take the 6th root because those always cancel each out.
3.1, 3.4652.
Okay, so what was it again? One more time.
3.46.
3.465. We'll start with that.
Okay.
Now, can you do that on these yellow calculators? Yes. If you look on the yellow calculator.
It's on top of the
It's on top of the caret, which is like the fifth one down, I think, in the first column. Girls, you're going to have to find this on your own. So underneath the caret, so you would hit second and then the caret button to get this amount. And then you want to make sure you put 7 over here and get 6,000 in here. Now, this, if I take the 7th root, those 7s are going to cancel out. What did I have left underneath that radical? 1 plus r, which is 1 plus the rate. But I'm still trying to get the rate by itself. Subtract 1, and you get an answer of r equals 2.465. That is your answer as a decimal. They wanted it as a percent. How do I change a decimal to a percent?
Move the decimal to the right.
2 to the right, multiply by 100, right? So 1, 2 is 2 places to the right. So this rate is 246.5%, or if you want to round it, 247%. Well, no wonder we went from 3 snails to 18,000.
We didn't have to add the 5 to it. It would just be like 2.46%.
Right, or if we're rounding it, yeah. Any questions about that? So that, it seems very logical when you go through it, but the first time I saw it, I was like, eh? So, any questions? I think that's kind of cool. It's like, oh yeah, we can take the 7th root, because we do that all the time. No? No, we don't. Questions on this? All right. Got a question? Okay. So let's go on to the last problem here. Now it says, by what percent did the snail population grow each month? You're like, who cares? No. I know. I see how you are. So again, we start with our major formula. I'm a big proponent of writing down the original formula as it is. Then write down what you know. This ending amount was 18,000. We started with 3. We have 1 plus. Now, that rate, because that yearly was a yearly rate, that is not going to be something we can just divide or multiply by 12, okay? So that's got to stay as some r. Our time was 7 years, but we want to calculate it per month. So any ideas as to what we could do here to find that time in months? Yeah, multiply this time in years by 7 or 12. I said that so matter-of-factly. 7 times 12 is 84 months. So we're going to see over those 84 months what that range was. So this equals 84. So, as Rachel said before, what's the first thing I should do? Divide by 3. 3's cancel out. We get 6,000 equals 1 plus r to the 84th power, which we got by taking 7 times those 12 months. Now, what the heck do I do here? Which means I should take the 84th root. Because if you have something to the 84th power, then take the 84th root, those would cancel out. And then you have to do that on the other side. So finding the 84th root of 6,000, what number times itself 84 times?
rounding up. Well, it's original is 1.109.
Okay, and yes, we'll round it to the hundredths place. So 1.11 is equal to 1 plus R. I'm trying to solve for R to figure out what is that monthly rate. So subtract 1, and you get 0.11 is equal to your rate. That is the decimal form.
Wait, 1.1.
Yes, but then I subtracted 1 because we want to get R by itself. And how do I change that to a percent?
2 decimals to the right.
2 to the right, which means that this is 11% per month. 11% per month for 84 months. Okay. So, there it is. Land snails. If you see one, just leave it. Don't take it home. Any questions about these 3 questions here? Do you have something at the bottom of that page? What does it say? Something about a calculator or something? What does it say?
Using a calculator, determine how long does it take for the population to double.
For the population to double. Using a calculator for the population to double. We don't have that here. Wonder which population they're talking about. The 18,000, do you think?
I mean, yeah, because they're dead, right?
Huh?
I mean, yeah, because they're dead, right?
Right. Okay. Using a calculator, see how much it would cost to double. Well, I mean, from 3 to 6, that's doubling, but that's very different from 18,000. Okay. Just curious. All right. So that is all the lesson that I have for today. Homework 1, I talked to you about yesterday, said you're going to have to do like 10 entries per table. There's 2 tables. Now you can also work on homework number 2, which is a Ponzi scheme. Now, when you decide to do homework number 2, you can work with pages 102 and 103 in your book. With that, where you might have to write down some things. Okay? But, man, we like flew through that. But I knew she needed to work on her essay today, so, all right. If you have any questions about the homework, 1 or 2, I will be happy to work on those with you. I did want to show Rowan and Che. I'll give you guys your tests so you can see them. Or actually, can you come up? Do you want to come up and see your tests?
Yeah.
Okay, come on up.